All right. Hey guys, we are back with the second session on IPFS and decentralized storage. I have here with me Ganesh, who is the platform innovation lead at Acumen Technologies. Ganesh background is really interesting. He was a part of several IoT startups, and he's also an investor, and also he's one of the few contributors from India, both to Ethereum Research as well as IPFS. So that's something awesome. I actually call him the Vitalik of India. I think that's pretty accurate. So yeah, Ganesh, the stage is all yours.
Hey, thank you, Shrikar. Glad to be here and share some of the knowledge I have gained through the community. Uh, Welcome, guys. Good evening, everyone. As Shrikar just introduced me, I'm Ganesh, and I lead platform innovation for innovation studio here in India, Bengaluru. It's called Acumen Innovation Studio. It's from Acumen Technologies, and we have been working on some interesting applications and protocols that leverage both blockchain and AI. And we've been doing it for quite some time now. For the past 3 years, we've been doing this. And I'm here to, share some of the information I have, some of the knowledge I have gained from the community about IPFS and how it can really help us decentralize and reduce the cost in our journey towards the next survival phase of humanity and maybe the growth. So we'll get started right away. So just so you know, this presentation right now that you are able to see is actually on IPFS, and this is the hash of that presentation file on IPFS, which is rendered through a special plugin which is made available by the IPFS companion plugin for browsers available on Firefox, Chrome, and other couple of browsers. So as I'm speaking about IPFS, I'm really practicing the values of IPFS as well. So a little bit about me. I have been coding for the past 10 to 12 years, and I just love that, and it's a great part of my life. I specifically focus on distributed systems and the backend and the bare bones of the internet. And more or less, I've been associated for the past 6 years with distributed systems background like IoT, AI, and blockchain recently for the past 4 years. So this is something I do for my bread and butter, and I've been doing it, and there's a lot of fun while I'm actually at it. So I'm one of the co-founders and maintainer of KIP Foundation, which is a new protocol that we are developing, which is taking a much more scalable approach towards decentralization without having to limit itself to the designs of a blockchain and inherent the good parts of it and actually make it a little bit larger. Then I've already told you about Acumen. So I also am the founder of a AI testing suite for chatbots. It's called as Texa project. It's a 100% open source project. We'll talk about that later, and we'll see how Texa is using IPFS. And I have also floated a couple of startups in the field of IoT, technical consultancy, and e-commerce, and all the other things for the past almost 10 years now. And recently, since 2018, I've been one of the moderators at Ethereum Research, which primarily focuses on the long-term innovation required for the Ethereum blockchain. And for the past 3 years, since 2017, I've been a promoter, member, and contributor to IPFS. I started off by contributing in the community, more on the documentation, communications, and spinning new ideas on top of IPFS. And recently, I've also been contributing code and making IPFS slightly better and giving back my part of the knowledge. And I'm also writing a new book, which is an upcoming book in the month of August. It's a book on how to use AI and how to converge that with blockchain for some practical real world implementation and real world scenarios. So I'm targeting that book for somebody who is really interested to switch their careers from any IT or non-IT background to blockchain. I know a lot of people who actually don't have a CS background, but they're really sound in understanding blockchain and there have been some of the successful people I know in blockchain, and I strongly believe in that. And I have trained a couple of people from different backgrounds get onto blockchain, and they're now open source contributors to projects like Ethereum. So I strongly believe that, and I've been asked many times to write a book. So I finally got some time in this lockdown, so I've been able to push something out, and I'm author of that upcoming book, which will be explaining about how to use IPFS and how to build something really scalable and really that makes sense for real world practical implementations. So let's get started about our presentation. What are we covering today? We're just trying to understand some of the limitations or the problems that we are facing in today's web. We'll try to go through them to try and understand some of the troubles we are facing. When we get data in less than 60 milliseconds or 40 milliseconds from a server, we think that it's all too easy and it's just too simple to make it happen. But a lot of complications that we don't see behind the screens. I'll be just, taking us into a small peekaboo there. Then we're going to have a very quick introduction about IPFS. There are a lot of YouTube videos on IPFS which you can go find, and I have also spoken about IPFS in the past 2 years. There are some videos which we can always look into. But in this particular video, I've been told by Shrikar that there is a very interesting audience. So I want to go from the basics and explain and just explain at a top line level, which is common to everybody. So I'll be sharing some interesting facts about IPFS. And then we'll go through the basics, the basic characteristics of IPFS. And then we'll do a very quick demo session where I'll show you how to install IPFS and how to actually spin your own IPFS node and how to add files into it and how to read them remotely and do all that. And we're also going to quickly go through the pros and cons of IPFS the way it is today and how we are all working together as a community to make it better. And very interestingly, there are a few applications in India which are using IPFS for some real world use cases. So we'll go through them very quickly. And we'll also help you guys understand how to start using IPFS in one of your dApps or one of your traditional applications and how you could benefit from that. Okay, so we all have been using internet, and I've been enjoying, and the realm of internet is something which is totally innovative, right? You get to share information between people, and with that quest to know more from another person or another source comes a little bit of inefficiencies, which we usually don't talk a lot about because it's all the bare bone infrastructure. So let's take a look at them one by one. This is a slide that I actually scraped off from Juan Benet's presentation he gave to the W3C Council. This was back in 2016. So this slide basically highlights some of the serious problems which we don't see on a day-to-day basis, but are already inhibiting us from innovating further. So if you look at the censorship problem, right? When we say that internet is open and pretty much anyone can access it, we really have to think about that again. And if you think about that, you will understand that although there is a need for freedom of speech for every user on the internet or on the web, we have this problem where people can just say, okay, I'm just going to block the site because I want to secure my community or my country or my locality from getting into some kind of scuffle. Well, that's great. That's great. But in the name of that, I think in the name of preventing some people from creating some kind of scuffles, we end up actually censoring a lot of useful information, both from the academic background and also from a practical, factual information point of view. So we have seen a couple of countries actually, having a very stronger hand on censorship, and that is a serious problem that the internet for the past couple of years have tried but severely failed to actually overcome. And then we have the offline usage problem today, and that can be better explained with the help of a simple application like a document collaboration tool that we have today. So a lot of people are trying to access the same file, and they're probably under the common roof, but every single one of them are expected to actually go to that source, which is a server probably sitting back in the US or some other remote geography, and you're expected to read it all the way from there. And regardless of if there are 10 users or 100 users under the same roof, they're all just senselessly going and talking to a remote server. So the problem now is you have a bottleneck, and if all of them are connected to through the same router or through the same switch, and if that goes down, you definitely have a problem because temporarily you are offline. uh, that has to be fixed in the interest of better collaboration. Then we have some security problems, and more than security problems that we have today in the internet, behind the net. Let's talk about one of the practical issues that we have today on the internet. Uh, you know that every single logo or every single image on the internet today has a URL, right? Now, you have brought something up on the internet, but unfortunately, even if you don't have any intention to bring it down, but you have actually moved that uh, file from one folder to another, since it's addressed by the name and the complete address, the not the relative but the absolute address, that file will no longer be accessible because it's a 404. It's not accessible in that particular location. So uh, millions, if not billions, of URLs are probably broken when we talk even as of now, and that creates a lot of information gap between people or processes. Uh, that is not only a technical problem, that's a different problem altogether. It's also a process problem, which makes it costlier for us to fix that. It takes a lot of time and effort. We'll talk about that in more detail now. But before that, let's also talk about the bandwidth problems that we have today. So I'm sure all of you guys use YouTube and Netflix and all these great content delivery platforms. They provide content in the form of videos, and it could be entertainment, infotainment, or anything else for that matter. And if you think of one of the most famous video on the YouTube today, or well, at least in the back a couple of years ago, it was Gangnam Style. So if you guys just think about how wild Gangnam Style trend was, uh, a lot of people were playing it on their own. Either through SM, they got to know about this cool song, or they actually said, "Hey, here's something I need to play again." So more of them played it, and they played it again and again. So every time it was being played, as much as YouTube is distributed and it's made efficient, I'm sure, there is still the client server model, which brings a lot of bandwidth problems today because you have to get that video, fetch it remotely, and then you need to be able to serve it locally among n number of clients, and that creates a lot of bandwidth problem. So if a couple of people, like let's say 30 people, really want to access Gangnam Style, and if it has to go through some 8 links or switches over the internet from one corner of the world to another, and if that video is 200 MB, I mean, maybe subpar quality video, right? That is easily 48 GBs of bandwidth wasted right there. And we also have another problem today, which is, we talk a lot about IoT and we can see where the connected economy will go and where it will drive us. But we have a very poor network connectivity among different devices altogether, where an IoT device may not be able to communicate with another separate device coming from a different manufacturer or different architecture altogether. And this makes it more of a siloed or channeled communication between an IoT device and a cloud, and then cloud to a device like a laptop or something. We think we should mitigate that in order to make sure that it is all connected, but not all of them have to go through, again, a client server model. So these are some of the problems we are talking about today, and all these applications are doing a great job in actually helping us get knowledge, but it looks like we are in the early days, and there is definitely a lot of room for improvement. So what really happened? So Juan Bennett is the founder of IPFS. He started IPFS project and the company behind it, Protocol Labs. And he started it in 2014. And that startup got picked up by Y Combinator as as part of their summer bootcamp, YCS 14 batch. And what's the motivation behind IPFS if these are the problems, right? Uh, as per the knowledge we have from community and a lot of information we have about the history of IPFS, we can learn that a lot of people actually had this problem that knowledge should not be just limited to a certain class of people, or it should not have any requirements. This is a philosophical one and a debatable one, but one of the core motivations for any sharing platform today, if you see or if you think about it, right, including something like Bitcoin, uh, could create controversies on the pros and cons of it. But the fundamental philosophy of making sure that everybody has an equitable access to internet or the knowledge that the internet can provide, that is something we probably won't see everywhere. So there is a need for access to crucial knowledge, and that should not be just limited behind a paywall. So if we fix that today, is that problem over? Not really, because you also have the problems of the broken URLs and other inefficiencies apart from the alignment problems in terms of philosophy. So you need a global namespace for any single data or every single data which is available on the internet. So if you combine these two together, you will see the vision or the motivation behind IPFS, which was, for developers who are part of this meeting, I think you guys will get it more easily, is to have a version file management uh, as part of like a Git styled versioning system with commits and all. And at the same time, you should be able to share that information to everybody in a peer-to-peer fashion. And to do that, uh, I think the crucial innovation here was to combine them together. And doing that together is something which led to the alpha version of IPFS, which was launched 5 years ago in 2015. So, what exactly is IPFS? If you think about it, it's a peer-to-peer network which allows people to share information without any of the problems like censorship or the URLs being broken because it's addressed by the name, or because there's a lot of bandwidth problems because everything is centralized. So these fundamental problems have been broken down and they have been addressed by IPFS. So IPFS solves this today with the help of 5 fundamental features, I would say. There are a few more, but I would consider these are the fundamental features of IPFS. Uh, One is identity. You need to make sure that every single node is addressable. So you have when you set up IPFS node, you have the opportunity to create your own public key and private key for that particular node, just the way you have a public key and private key for every single Bitcoin wallet address. So that's the identity part where every single node can be addressable. Once you have the node, through the node you actually write some data into the network inside the node and then network propagating it. So for that, what IPFS does, similar to Git or any other file versioning and branching systems, you can actually see that every single file is broken down into smaller blocks of up to 256 kbs of information, and that block of data together will become a list, and organization of list together will form a tree, and every single change or the version changes that happen to that particular file or that particular data could could be a comment. So this is how files are organized in a conceptual and a very high level uh, in IPFS. So once you have these files, what really happens is somebody would probably want this file, and they will not say send me cat.jpg. They would say send me the data of this particular file which goes by the hash. And these networks basically broadcast themselves saying that, don't worry, I got you, I have this file by this hash, so I'll provide you. So to make this happen, even in BitTorrent, one of the earliest peer-to-peer file sharing network, they also used Kademlia based secure Kademlia based buckets, which allowed every single node to say that, okay, let me keep a track of who has what, right? So that is what the networking aspects of IPFS actually does. It broadcasts the information of who has what. And the best part again here is that when we talk about networking, it's actually not IPs again, just the way you have it on the traditional web. It's actually the multi-address of that particular node, which is very important here, and not the IP, which is another abstraction which will secure us from these broken links or some other access problems. That's networking, and you have the file, and you can give it. So how does the exchange really happen? So this is where one of the core innovation of IPFS comes in. It's called as bit swap protocol, which basically says I have a giver who will basically transmit the data in the form of blocks uh, to the taker. The taker is the person who has been asked to get that data by a user. We'll actually see some of the practical use cases of this in one of the demo sessions I have planned in the next 10 minutes. So we'll explain a little bit of that there. Now, finally, when we talk about a website on the internet, like google.com, twitter.com, or linkedin.com, you have one namespace under which you see a lot of changes, like a new post getting posted, or somebody wishing, or you see a whole new theme altogether in a couple of days, right? So all of those changes you are observing today without having to change the name where you do the lookup today, right? So one of the other best innovation, the core innovation that IPFS was able to do is that with all the cryptographic changes that actually happens to the file every time you change it, they are able to manage all those changes and have a mutable pointer which will point to the latest data, latest files that belong to a particular namespace. And in your case, it might be, let's say, xyz.com. So it's a xyz.com in the form of a IPNS instead of a website or a domain name, which usually goes by the technical term as a common name. So the concept of common name on the traditional internet, where you have something like google.com as a common name, that has been interpreted very nicely, very easily in the form of a common name in IPFS as well. And that is called as IPNS, which is interplanetary naming system. So these are the basic concepts. Let's quickly move towards the demo of IPFS. I'm gonna quickly stop sharing my screen now.
In the meantime, guys, if you have any questions, feel free to ask it in the question section. Or if you have any questions for me, you can even send me a private message or send it in the chats.
Okay, so are you guys able to see my terminal?
No, Ganesh, I think you have to share the screen again.
Okay, I think that didn't work. So let's try that again. How about now?
No, can you click on the share your screen option below in the down bar?
So I did that, and I think
It's not coming, is
I
it?
guess
Oh
I
yeah,
should
now we
probably.
can see. Yeah, yeah.
Okay, great. So you guys are able to see my terminal screen now, right?
Yeah.
Okay, great. Okay, so uh, the IPFS can be easily installed, and as long as you guys have Go installed on your laptops, you can actually easily install it with go get github.com/IPFS/IPFS update, which will install the Go package of IPFS update. So I have it already installed. So it's showing me some of the version issues because I also have a change that I'm making to that particular project. But let's not worry about that. Let's directly use what I have installed in the Go bin. So once installed, if I just use IPFS update install and just uh, mention latest, it installs the latest version. But the changes that I have on my systems for that reason, I'll be installing v0.5.1, which is the latest stable version of the build, which was 0.5.0. That was a major update that we received in the month of April. So with a minor patch, which actually fixes it. So if you're interested in installing IPFS, this is the best way to do it as long as you have the Go installed. There are other ways to install it which are available. The binaries are also available for you to easily install. So mine is installed. So let me show you what really happens when I do IPFS in it. I basically initialize a particular folder where a new private key and public key will be generated. Since I already have my IPFS repo in that folder, it's not allowing me to. So let me quickly, for the sake of your so now let me try IPFS init again. So you guys can see that it initialized a new IPFS node at this particular folder, the default uh, path, and it's generating a 2048-bit RSA key pair. You could, of course, change this to ED25519, depending on your requirements. And what it does is it creates a peer ID, and it basically has created a folder with these basic files where the config basically has all your configurations. I'm not going to be able to share that because it has the private key, but you will get the picture if you do this on your own. What's interesting is how the data will be stored in the form of those tiny chunks that I told you about. So these are some of the blocks which actually are sharded for every single file. So to add a file to the IPFS network, you can simply just use the command IPFS and a subcommand add, and whatever local file you want to add, you can simply just type that name and you'll be able to add that file. So I'm a bit of a trekker myself, so I'm just going to go ahead and bias myself for adding a Mount Everest photo. And I have completely stored that photo, and the JPEG photo is of the size 759.9 KB, so that got added, and here's a hash. So before we go and actually read the file, let's try to understand what really happened here. If you see now, if I just do the ls again, you can see there are a lot of changes that happen, right? So you see a couple of new folders that have been created. Actually, the number of rows also have increased. So it was previously 6 and now it's actually 7. So all those tiny folders are having the smaller bits and pieces of the file. We cannot say which folder has which part of the file exactly. And to do that, there is something else which is called as a Merkle DAG Explorer. We'll try to show some of that, which is a technical deep dive hands-on into the protocol in another session. But just for your understanding, you can now see how the whole organization of this folder has changed, which means every new file translated into smaller chunks of data which sits on this particular folder blocks. Now, let me just go ahead and let me try to read this file. Of course, I can read the file on my terminal too, but as we know, it's a binary data, so it doesn't really matter. But we need to view this properly here in the UI, where you can see that my new photo will try to access it now. It's not accessible right now because I have not turned on the daemon, which is very important every time you need to have the daemon on if you have to share that. So right now, the taker is one of the servers which is run by IPFS back in the US, and you will see now this node being a giver. So a giver is now talking to the taker, and we'll just try to refresh, and here we go. So this is Mount Everest, a pretty decent high-res photo without any compression problems. I'm able to actually upload it immediately on the IPFS. And what's interesting actually is that it's actually reading it. Once the transport is over, it's actually reading it from my local file. So it's impressive because today, even if you have, if you have logged on to Facebook or any other social media platform or content delivery platforms today, they actually don't allow you to host any data. You have to read them all over again. Maybe a part of it is cached, but it doesn't really give you a sense of ownership because that's all Facebook's assets. But here it's like almost like BitTorrent, where you could just keep that data as long as it's technically usable. And this is an open source image from Unsplash, so I can keep it and I can cherish and I can actually share it with all of you. So let me go ahead and do that. I'm just gonna go ahead, click on copy shareable link, which is actually a proper DNS link, which is for IPFS DWeb. So if I go and execute this, I can get it, and so can you guys. So you should definitely go and access it there. Now let's come back. Okay, I guess it again loaded back on the local. So I should actually share you the raw link. That will make sense. Yep, that one, the second one. Uh, so what did we do now exactly? We were able to set up IPFS. We were able to actually add files to IPFS, and we were also able to read files from IPFS uh, through the terminal as well as the web browser. So I'm almost running out of time. I want to show you how to actually create key value entries for your application, and then quickly move on to the applications. So it will be a really quick one. Uh, so I've actually built a very small, very simple library which allows you to actually write key value entries like what you do today with MongoDB or other databases. So it's a Golang script. It's a piece of code. It's a single program file which actually connects to an IPFS daemon. In this case, I have chosen Infura. You can choose local host as well to talk to your IPFS node. And you should be able to actually create a mapping where for every key, there is a value which can be of any type, but the key has to be string. And then you actually convert the whole mapping into a JSON object, and then you actually write it by calling the set call, which is the library that I've written, where it actually uses a function called DAGPut, which writes it to the Merkle DAG of IPFS. So this is a very shallow explanation. I would love to take another completely different session to explain you how the insights work. But let me go ahead and let me quickly run this Go file. So it's asking me enter the value for the key field. So let me put Bengaluru as the key, and the value, let's say, is Bengaluru is psych. So Bengaluru is the keyword, the value is psych, and this value could be pretty much actually anything, and that's the reason why we have an interface definition. And what's actually happening right now is now that I've entered the key and value, it's actually calling set, which internally writes it to the Merkle DAG of the IPFS, and it returns a CID for that particular key value entry. So I'm just going to quickly show you how to read those values. Just the way today you have MongoDB Collection Explorer, something similar we do have, and we have it for the CIDs. And I just put the hash, the CID hash, what I receive, and go ahead and click on Explore. What we need to understand is the data. The Bengaluru is psych. This data is actually not written to my node. It's currently being written to one of the servers hosted by Infura. Now, if I change this, it's immediately written to me and I can view it. There's a purpose why I didn't do that, and you will see that now. Although UI typically takes some time to actually get the data, let me just use the command line, which is far more efficient. Now it's querying the network, it's querying the IPFS network. As a taker, it is querying who can give me the data for this particular CID. So it's querying as we speak to some of the global servers, all of them who are hosting IPFS nodes in a peer-to-peer fashion. And over time, I will be receiving that particular data. And you must have recalled, if you guys have experimented, at least some of the torrent browsers or applications, you would have observed that it's very, very difficult to actually download a particular file. It's because of the bandwidth, which actually has to be spread across everywhere, and it's completely peer-to-peer, and there are a lot of leechers for that particular data. So IPFS is also getting better. It's going to take some time, where we can say that this small command to read a key value can get very quick. And until we get there, I'm just going to go ahead and let's see. Okay.
Hey Ganesh,
Yeah.
sorry to interrupt. Like we are running out of time, so you
Yeah.
just have
Yeah,
yeah, you can
I
take.
think we need to take this on a separate session. So I'd be happy to do that on a different meetup. But you are able to create a key value, but not so efficiently directly on top of IPFS. And the pros of IPFS are pretty simple, right? Censorship resistant. As long as you have the hash, it could be through any gateway. As long as they are able to offer that data, they will be able to offer it. And if they are not able to offer it, they'll still go query some other neighbors and get it for you. Think of it as like that, right? It's a very cheaper alternative to blockchain for data, because you really can't store a PDF or any business related data except for the logical data on top of a blockchain. It becomes really difficult. Just to store the Ethereum yellow paper back in 2018, the estimate was around $2,000, I think. So 2,000 to $3,000. So just to store 3 MB or 2 MB, something like that, if you're paying that much of fees, that's definitely not feasible. So how do you get the cryptographically verifiable opportunity, but at the same time, how do you do it at a cheaper cost? IPFS. Finally, it's actually not just for blockchain. It should be for any traditional applications which also need security and gives some degree of ownership back to the user, and also reduce their cost and increase their efficiency also. That is also possible through IPFS. And you just saw one problem that we all observed, right? So there are no read guarantees. Public IPFS gateways are typically slow. There is so much data being written to the network, and there is clearly no priority for which data has to be given first. Although programmatically done, the demand from a particular geography can never be predicted. So that is something a lot of people are working on, and we'll talk about that in a separate thread. But to make it nearly accessible, you need to have your own node, and that's the only way you can actually get the data instantly and have that ownership. And one important thing is that this is again something which has to be demonstrated to explain and get some more clarity on. File changes are pretty much costly on IPFS, so you just make a change to an existing document, and that becomes a completely new hash, which means you are hosting a node, but you are actually duplicating your efforts or duplicating the cost in hosting one file which is being used, but the other file no longer being used, and that's just waste of resources sometimes. So who are using IPFS in India? So is it something which will revolutionize just the way torrent revolutionized access to information? I think it will, and there is a very steep issues in understanding cryptography and some of the problems in IPFS. And unlike blockchain, IPFS is not directly related to any cryptocurrency, so that's another reason why not a lot of people are psyched about it. But I guess we'll get there. And one of the products from Aicumen, which is an open source driven product, is called Tracy, which actually focuses on providing privacy first home quarantine management for the coronavirus COVID-19 patients that uses IPFS. And one of my own project, which actually tests AI chatbots in the testing suite, we also use IPFS there to publish the AI's test results to be more transparent about the efficiency of AI and what kind of data is used, just to make sure that the AI isn't biased. So that's all great, Ganesh. So I'm a developer. How do I get started with IPFS? Now, you saw in this very small demo that it's a little bit tacky for you to immediately get on with IPFS. Although we would definitely want to see full, complete decentralization as the light of the tunnel, I think we should start somewhere. And this is something we have been working at Aicumen. So we have a decentralized storage as a service API for a bunch of nodes which are geographically replicated, and nobody in our operations have access to that data. So we have been able to enable developers like you guys, but unlike other centralized cloud service providers, we don't have access to that data. Let me put it this way: we don't even know the hash for your data, right? So that's the level of privacy, anonymity, and the enablement that we give for developers who want to start using IPFS in their traditional apps or dApps or anything. And there are a couple of others who also do this, but they have some issues with tokenomics because they don't actually charge people by USD or stable currencies, but they actually do it with tokens, and that kind of hampers the early stage of adoption of IPFS. This is something we have been able to analyze. So we are pretty clear that the initial days of Moibit has been tokenless fee model. Unlike the private public IPFS gateways where we couldn't actually read the CID immediately, in our case, we will be able to because it's heavily distributed, but at the same time, there is a read guarantee because we maintain that SLA. And we want to make sure that your data or your customer's data has to be safe. So we strictly allow client-side encryption, which means even the guys who host the IPFS nodes, they don't get access to your data. Guess what? That's not going to happen. All of this is all possible today with the help of NPM. My guys will be able to actually share the link with you on the NPM, and I'd be happy to share it as well. There's a couple of us from Aicumen who I think have also joined this meeting, so we'll be happy to answer any questions on Moibit. And we integrate it with a real blockchain like Matic Network, which can be used today to deploy any enterprise use case or a socio-technical use case. So that's completely possible today. And Tracy actually uses both. It uses Moivate and Matic. So that's a live use case. And if you sign up, you get 2 GB free space on the IPFS cloud that we have for Moivate. So yeah, that's about it. And if you have any questions, I'll try to address them in limited time, whatever we have. And sorry if I've belabored.
Okay. Awesome, Ganesh. That was a great session. I wish we had more time, but yeah, unfortunately, we're running out of time. We can take one question, which is the most upvoted. It's again by Harshad. Is the file stored in every node similar to how an entire blockchain is maintained by all the nodes in the network?
So that's an interesting question, right? The analysis, if you do, the fundamental analysis tells us why blockchain is really costly. In blockchain, you are expected to actually manage the state, and every node has to manage the state. There's no other option for consensus. That's the criteria for achieving consensus as such. In IPFS, it's not necessary that if you add a file. So if I added that Mount Everest photograph to my MacBook or the IPFS daemon running in my MacBook, it's not guaranteed that that particular file is available in your laptop or in your server. There's a way to manage this guarantee. It's called as pinning. It's an external way of actually maintaining replication of the files. So that is possible, but it's not a default option that you would want to expect. But the best part is if you have read the file and if my node goes down, nobody has to worry because you have it and you can help others actually get that file. So that's the plus point though.
Okay, awesome. So rest of the questions, I think we can take it in the chat section, right?
Yep, I'll address them. Yeah.
Yeah. Awesome. So thanks so much, Ganesh. That was a great session.
Sure.
Yeah. So where can people reach out to you? I have just shared your Twitter as well as your email. You have any closing remarks?
I think it's actually very early stages as we speak about the entire decentralized movement. We are just in for 10 years, right? Uh, AI started back in the 1950s. This is something I've covered in the book also, which is very interesting. Alan Turing and his gang of intellectual professors who joined back in England, and they termed this they coined this term, and they did all this, right? Just imagine if AI is actually picking up now, and if that was actually started back in the 1950s. Just imagine the future of decentralization just a couple of decades from now. So whatever friction we may have today is all just part of the process, and AI as a successful domain today has actually come through the tunnel. So will we. It's just a matter of time. So until
Yeah.
then, keep learning and start using the technologies as well.
Yeah, just a matter of when, not if, right?
Exactly.
Yeah, awesome. So, guys, we'll be back with the next session in a few minutes. You can ask Ganesh questions on the direct chat as well as on the chat section, and I think Ganesh will be there in the. He'll be attending the session, so you can interact with him. So, we'll see you in a few minutes.